Hi, everyone. Welcome to another one of my awesome little videos. Um, just to let you know, there are going to be some questions that you're going to have to answer, and let's get started. We are going to look at matter and change, and some of this information is absolutely review for you, but in order to understand physical and chemical changes, we need to just review and make sure that you understand the basics. So let's go ahead and let's get started. So here we go. How does one describe the quantities of matter? Now, remember, we've been looking at how to measure matter. And if you remember, one of them is volume. Well, volume is the amount of three-dimensional space an object occupies. So if we were to do, say, a rectangular prism, we could do length times width times height. If we're doing an odd shaped, remember we did what was called water displacement, and that could give us the volume as well. We also have something that everybody knows about, and that's weight. That can give us kind of a quantity of matter, and that is measured the gravitational pull of matter on an object. Okay, and that's kind of what your scales do at home, that you have sitting in your bathroom if you have one. You have a plate, and you step on this plate, and the gravitational pull from the earth on your body will pull you down, pressing the plate down, and then voila, you have your weight. Okay. Well, here's the problem. When we start thinking about how to measure the quantities of matter, we have to look at reliability. Well, volume and weight can change depending on temperature and location. So if we were to, say, take a liquid and freeze it, what happens to liquid when we freeze it? It expands. So the volume would expand. Okay. Well, what if we were to take something that weighed, say, 15 pounds here on Earth and take it up to the moon that has a significantly less amount of gravitational pull? That would actually weigh a lot less on the moon than it would here on Earth. So volume and weight will change depending on the temperature and the location at the time. But we do have something that is a little bit more reliable, and that is mass. Mass is a reliable way to, to measure matter. And again, remember, we measure mass based on a balance, okay? We don't base it on a weight of gravity. We base it on a balance back and forth. And these are just two different types of balances. This one is a triple beam that you're used to. And then this one also is a very basic balance that you would probably see in a preschool. So mass is the measure of the amount of matter, not weight. It doesn't have anything to do with gravity. Mass is not affected by temperature or location or any other factor. How much you have is how much you have. You're not going to have less in any way, shape, or form, and you're not going to have more. If we had a piece of ice and we melt it, we checked for its mass, and then we melted it and checked the mass again, they would be identical. They would still be the same. If we were to take that same ice cube, say, and measure the mass here on Earth, and then we took it up to the moon and measured the mass again on a balance up on the moon, we would still have the same amount of mass. Okay, it's not going to change. So if you were to take a 100-pound person here on Earth and take them up to the moon, not 100 pounds, 100-gram person here on Earth, and we were to take them up to the moon, they would still be 100 grams. The only way to change it is to whack off an arm, and then obviously we would be changing their physical characteristic. So weight is a measure of Earth's gravity pull. okay? Not on how much is there. An astronaut will have a different weight on the moon, but his mass will remain the same. So you need to make sure you understand that. Weight will change, mass will never change. So here's the first question. Why is mass more reliable, a more reliable measure of the quantity of a sample of matter than weight or volume? So go ahead, and I want you to answer this question, and we'll talk to you in a minute. So the answer to that question was, the mass of an object is always constant. It does not depend on its location or its temperature. Okay? Mass is mass. So, hey, let's revisit this real quick. Let's go ahead and look at properties of matter. We know that matter is anything that has mass and occupies space. All right? We got to be able to know it's there, and it has to be have a measurable mass. Has to have a mass. So let's refresh. If we have a lot of kinetic energy, then we have a gas. The molecules really kind of stay away from each other, and they fill up the space around them. A liquid, a medium amount of kinetic energy, and they still kind of have a little bit of a bond, but they kind of slide past each other. Solid, very little kinetic energy. The molecules are kind of arranged nice and neatly, and they are really attracted to each other. And all they do is just kind of vibrate. They really don't go much of any place else. So let's talk about the characteristics of a solid. So there are four main characteristics of a solid. Solids have a definite volume and a definite shape. Remember, the molecules are all cram-packed together, and it's going to keep the shape that it's in, okay? Its volume is its volume. It's not going to change. The particles of a solid are packed tight together in a relatively fixed position. And the only way to really change their fixed position is to do something drastic, like, I don't know, crush it or something like that. The particles are held by a strong attractive force between them, and that's because there's too little kinetic energy for them to break that attraction. And particles of a solid simply vibrate about in a fixed position. Remember, they can't break free. They don't have enough energy, enough kinetic energy in order to break free from that attractive force. So now let's look at liquids. Characteristics of liquids. A liquid has a definite volume, but no definite shape. Remember, a liquid will have its volume, but if you put it into a round container, it's going to take the shape of that round container. If you put it in a square container, it's going to take the shape of that square container. So it has a volume, and the volume won't change, but it has no definite shape. A liquid will assume the shape of the container. It will fill every single part of that container based on its volume. The particles of the liquid are held close together, but can move past one another. They still have an attraction to each other, but they're kind of more, they can move past each other and kind of move a little bit more around each other. The particles in a liquid move much faster than in a solid. That's because they have more kinetic energy. This allows particles of a liquid to temporarily overcome that attractive force between them. They still are attracted to each other, but they're at least able to kind of space out a little bit more. All right. So let's talk about gases. Gases, we're talking oxygen, we're talking about carbon dioxide, helium, hydrogen. Gases have three characteristics. Gases has neither a definite shape nor a definite volume because they spread out. Remember, volume is the three-dimensional space that they take up. Well, a gas, remember that bond is broken. These particles can go in every which way direction that they want, and they will just move and spread out as far as the containers will allow them. All right. And that really makes it difficult to count on their volume as well. Gases are composed of particles that move very fast and are at great distance from one another. Again, that bond is that attractiveness has been broken and they are able to move rapidly wherever they are. And like I said, at these great distances, the attractive forces between gas particles are much weaker than those in liquids or in solids. They just don't like each other. So let's review on phase changes. When a substance changes from one phase of matter to another, there is no change in its composition. Ready? This right here is ice, but this is still just H2O. It's just hydrogen and a hydrogen and two oxygen molecules, H2O. And if we melt it, it's still H2O. And if we give even more kinetic energy and we start doing evaporation, we still have H2O particles. The particles are still the same. The molecules are still the same. Water freezes to a solid and melts to a liquid, but it's still H2O. It's still water. When a substances change state, the only change is the distance and the interaction between the particles that make them up. Okay, so it all depends on how close the particles are together or how they interact with each other. Meaning, are they really attracted to each other? Are they far, far apart from each other? So now let's take a look at properties of matter. This is actually what I really wanted to get to. That's why we kind of flew through those first few slides. We're going to look at properties of matter. Well, every substance, whether it is an element or a compound. So an element is what we find on the periodic table. A compound is a combination of elements. They have characteristic properties. They have things that actually make them what they are, or give us the identity of what they are. So these properties are used to distinguish between substances and to separate them from a metallic to a royal noble gas. There are specific characteristics that distinguish them from each other. A property is a characteristic that defines an entire group of substances. For example, the property of metals is that they can conduct electricity. And most metals can. Some metals do it better than others, but they should all be able to conduct electricity. Now, of these characteristics, there's 4 types of properties. The first one is extensive, and these are the external properties. These are things that are really easy to see, and they actually depend on the amount of matter that we have. So these properties include volume, mass, amount of energy in a substance, and all of that depends on the amount of matter we have. If we have a great amount of matter, our volume will increase, our mass will increase, the amount of energy that's in it is going to increase or decrease. And that is all dependent on the amount of matter. So, ready? These properties are not very useful when attempting to identify a substance. Well, we just can't, because the mass can change, the volume can change, and it really changes. It can change from day to day. So these are just external qualities. Now, intensive, these are more internal qualities or properties. Intensive properties do not depend on the amount of matter present. So if I've got 100 grams of matter, it's going to have the same properties. If I say I have H2O, if I have 100 grams of mass, okay, my matter is still going to be H2O. So let's take a look. What are some examples? These are melting points. We know with H2O, a melting point is anything above 0 degrees. Boiling point. Well, a boiling point is 100 degrees Celsius. Its density, it's going to be the same regardless if I have 100 grams of matter or not. And is it able to conduct heat or electricity? Well, it can conduct electricity, but it can't conduct heat. But that's with all H2O. And it doesn't matter if I have 100 grams of it or if I have 1,000,000 grams of it. It can still either conduct electricity or not. It can conduct heat or not. These properties are going to be the same regardless, okay? It doesn't matter where I get the water from, the H2O, these properties are all going to be the same, okay? So for a given substance, regardless of how much of the substance that is present. Now here's the crux of what we're really wanting to get into, these physical and chemical properties. Now, let's go ahead and take a look. So we have physical properties and chemical properties. These are the ones that we're really going to focus on. Physical properties can be observed or measured without changing the identity of the substance. So these are things like tearing a piece of paper. Does it change the fact that it's still a piece of paper? No, it's still paper, regardless if I tore it in half or not. A skunk smells. Well, if I take away the smell, is it still going to be a skunk? Probably. A skunk is a skunk. If I boil water and it evaporates, is it still H2O? It is. So these are things that just doesn't change what they are. So the physical property describes the substance itself, rather than describing how it can change into another substance during chemical reaction. And these are things like the color of it. Red is red. The odor of it. Well, skunk smell is a skunk smell. How does it taste? Salty is salty. Sweet is sweet. Hardness. Is it hard? Is it soft? The density of it. Does it float on water? Does it not float on water? Its melting point, its freezing point. All of these are examples of just physical characteristics. Chemical. The characteristic that describes how a substance interacts with other substances to produce new substances. Now, these are things like the bangs, the pops, the creation of heat, changing paper into carbon. Those are chemical changes or chemical type properties. So these include things like to burn, the ability of charcoal, which is a carbon, to burn in air to form carbon dioxide is an example of a chemical property. Mixing, putting vinegar and baking soda together is an example of a chemical property. They react to each other. And we will get into more detail on chemical reactions. So, physical change. It's a change in physical properties, but there is no change in the chemical properties or chemical compositions of a substance. Ready? Ice turning into gas. It's still H2O. Paper being torn. It's still paper. Clay that's being a clay ball that is being smushed. It's still clay. All right. Red is the color red crayon is still a color red crayon. There's no new substance that's made. Paper, even though I've torn it in half, it's still just paper. H2O, if I add energy to it and it turns into a gas, it's still just H2O. It's a change from one phase of matter to another, from a solid to a gas to a liquid. These are just phases of matter. So, having an ice cube melt, that's a physical change. Taking an axe and chopping up this wood, that is a physical change. It's still wood, it's just in a different form. Boiling water, it's still H2O, even if it is in a vapor form or in a gas form. These are all just physical changes. Ready? Grinding, cutting, melting, boiling. These types of changes do not change the identity of the substance. All right, so chemical changes. We're really going to talk really long and hard about this. We're probably going to do a week or two just on chemical change alone. Ready? This is how you know you have a chemical reaction or a chemical change. Okay? It results in the production of one or more new substances that differ in chemical properties and composition from the original substance. So the formation of a gas. Ready? Vinegar. Vinegar is a liquid, right? Baking soda. Baking soda is a powder. They have their own chemical makeup. But as soon as you put them and mix them together, you now officially have carbon dioxide. We are now making carbon dioxide gas. If you add iron to water, you're going to get a color change, and it's called rust. And that's what this is showing you right here. You get that rusty look, and it actually will have a different composition than the original iron. Energy change. If we get lighter heat from it, if we take wood and we add heat or we add kinetic energy, it burns. And when it burns, then we no longer have wood anymore. We actually have carbon. Okay, but it produces light and it produces a heat. Heat is a big one. Heat is huge, big. And so examples include iron rusting. That's what this is. The souring of milk. And that's kind of what this one is. Ready? The lactose in milk, when you leave it in the refrigerator too long, it curdles the milk. It sours the milk. The burning of paper, that makes it create different, instead of being cellulose, now it is carbon. Okay, so let's look at reactants. Reactants, the original substance participating in a chemical reaction. Now, this is, if we were to look at reactants, the easiest one I could tell you about is vinegar and baking soda. Vinegar is a reactant, meaning it will react with another substance. So when you go and put it together with another substance, it will create another product. Okay. Put vinegar in milk and you get a sour milk, or almost like a buttermilk type of a consistency. And if you put baking soda with vinegar, then those are two reactants. You put them together and it creates carbon dioxide. So, and those are reactants, are the individual substances. And when you put them together, you get what is called a product. Products are new and different substances formed as a result of the chemical change. We add kinetic energy to wood, causing fire, which creates heat. And when it's all said and done, all we have left is some carbon, the burnt wood. If we add flour, salt, sugar, eggs, butter, all these reactants to get baking soda, all these reactants together, and we add heat to it, we now get a new product. We get a cookie. So reactants are the original substances all by themselves. A product is the new substance that they've created. Example, if we put carbon and oxygen together, we get carbon dioxide. Carbon and oxygen are the reactants, and carbon dioxide is the product. Alrighty, so you're going to do this one here. It says you need to indicate each of the following as a physical or chemical change. And these are actually going to be individual little questions that you're going to have to answer. And you should be able to answer them clearly on your own. This is as far as we're going to go right now. We do have other slides, but I will add another video when we get to those slides. Enjoy.